In this video, we will explore the relationship between polynomial functions, complex zeros, and degree. This is AP Precalculus topic 1.5. If you appreciate this content, please show it by hitting that like button. For each of the following polynomials, state the degree of the polynomial and determine all real zeros of the polynomial and the multiplicity of each zero. So when I look at f of x, in order to figure out the degree, in my mind I'm going to ignore the plus 3 and I am ignoring the plus 1. This tells me that the leading term of the polynomial would be, this is 4x squared times x, so this would be 4x to the third power. That means the degree of the polynomial is 3. Now let's go back and talk about the zeros. Setting this first factor equal to 0, I get a 0 of x equals negative 3. And that one has a multiplicity of 2 because of that exponent. But we also have a 0 of x equals positive 1 with a multiplicity of 1. I'm setting this factor equal to 0. Problem number 2, the degree, alright, again I'm just ignoring the minus 5 and the positive 1. So this is going to be x times x to the third power, that's x to the fourth power, times x squared, so that's x to the sixth power. So I know we're going to have degree 6. I'm going to get a 0 of 0 from the first factor out in the front, from this monomial. So I have x equals 0, and that has a multiplicity of 1. And then I have x equals 5 from this factor. Maybe I'll just keep lining them up. I have space. X equals 5. That has a multiplicity of 3. And then x equals negative 1 with a multiplicity of 2. Alright, problem number 3. For this one, I'm going to ignore the minus 9 in the first factor, and I'm going to ignore the minus 4x and the plus 4 in this factor. So this is x squared times x squared. That would be x to the fourth power. This is degree 4. I think I shall factor this the rest of the way before I answer anything else. I'm going to do that down here. So I have y equals, and this is going to factor, x squared minus 9 is the difference of two squares. So that factors as x plus 3 times x minus 3. Now this trinomial, I'm betting that's going to also factor. So the x squared will factor as x times x. Looking at this 4 on the end, that's going to factor as, well, it could be 2 times 2 or it could be 4 times 1. Looking at the middle, I bet it's going to be 2 times 2. Speaking of the middle, inner plus outer must equal the middle. When I say inner, I'm talking about the 2x. When I say outer, that's another 2x. Inner plus outer must equal the middle, which is this negative 4x. We control the signs. If both of these are negative, then I get a negative 4x out of it. That means both of these would have to be negative. So we factored it. I could simplify this a tiny bit more. Notice that this factor is repeated twice. So rather than recopy the whole thing, I'm going to erase one of them and make it squared. So now we can see that we have a 0 of x equals negative 3, and that has a multiplicity of 1. I need to move this down. We have a 0 of x equals positive 3, another multiplicity 1, and then we have a 0 of x equals 2. This one has a multiplicity of 2. Let us factor p of x the rest of the way. First of all, every term has an x, so that means x is a common factor that I can factor out, bring it outside of the parentheses. That's going to leave behind x squared plus 10x plus 25. I'm betting that this trinomial will factor even more, so let's get ready for that. X squared will factor as x times x. 25 is either going to factor as 5 times 5 or 1 times 25. Let's go for 5 times 5. Inner plus outer equals middle. Inner, we have 5x. Outer, we have another 5x. The middle is 10x. If we just leave both of these positive, that makes positive 10. So there we factored it. And combining this repeated factor, we get p of x is equal to x times x plus 5 squared. Ignoring the plus 5, we have x times x squared. That will be x to the third power, so the degree is 3. This x in the front gives us a 0 of x equals 0. That's multiplicity of 1. And then the other factor gives us a 0 of x equals negative 5. That one has a multiplicity of 2. Factoring m of x out the rest of the way. X squared minus 1, that is the difference of two squares. That can factor as x plus 1 times x minus 1. This trinomial, I'm sure, is going to factor. X squared will factor as x times x. 1 can only factor as 1 times 1. Inner plus outer must equal middle. Inner, I have 1x. Outer, I have 1x. To get a middle of positive 2, I would just leave both of these positive. So there we factored it. Combining repeated factors, we can have m of x equals, the x plus 1 factor appears 3 times. So we can write, I think I'll go ahead and write the single x minus 1 first. And then we have x plus 1 to the third power. Ignoring the minus 1 and the plus 1, we would have x times x to the third power, that is x to the fourth power, so the degree is 4. From the first factor, we get a 0 of x equals 1, and that one has a multiplicity of 1. From the second factor, we get a 0 of x equals negative 1. This one has a multiplicity of 3. Let's factor number 6 out the rest of the way. We have 4x to the third power. I'm betting this trinomial will factor more. X squared is going to factor as x times x. 8. 8 is either going to factor as 2 times 4 or 1 times 8. Looking at the middle, let's go for 2 times 4. Inner plus outer must equal middle. Inner, we have 2x. Outer, we have 4x. To get a middle of negative 2x, I need the signs to be positive and negative. So that means a positive 2 here and a negative 4 here. Notice positive 2 times negative 4 does give us negative 8 as well. So we factored the first trinomial. Now let's go ahead and factor the next trinomial. X squared will only factor as x times x. 20. 20 will either factor as 4 times 5, or 2 times 10, or 1 times 20. Looking at the middle of positive 1x, let's go with 4 and 5, because those are 1 apart. So 4 times 5. Inner plus outer must equal middle. Inner, I have 4x. Outer, I have 5x. To get a middle of positive 1, the 4x needs to be negative and the 5x needs to be positive. So negative, positive. Let's now combine the repeated factors that we see. So we will have 4x to the third power times x plus 2 times x plus 5 times x minus 4 squared. Looking at only the leading term of each factor, I have 3 x's, then that's 4 x's, 5 x's, and 2 more makes 7. So this is degree 7. And now we have a 0 of 0 from the monomial in the front. So we have x equals 0, and that's multiplicity of 3. And then we have x equals negative 2 with a multiplicity of 1. And then we have x equals negative 5 with a multiplicity of 1. And finally, we have x equals 4 with a multiplicity of 2. Given the following complex zeros of a polynomial function, determine the conjugate that must also be a 0 for the polynomial function. Conjugates are like a plus bi and then a minus bi. So for the conjugate, we are just going to change the sign of the imaginary term. We're going to leave the real term alone. So the conjugate here is going to be, we leave the negative 1, change the sign of the imaginary. So there it is. For number 8, it only has an imaginary term. You could think of it as 0 plus 4i, and then the conjugate would be 0 minus 4i. Or you could just say, we'll just change the sign of this imaginary part and put negative 4i. Similarly, for number 9, we only have an imaginary term, so we will change the sign for the conjugate. Positive 3i will also be a 0 of the function. A polynomial has the following zeros. Determine the least possible degree of the polynomial. The degree of a polynomial matches the total number of zeros, including imaginary zeros and multiplicity. So to find the least possible degree, all we have to do is count up the number of zeros that we can be sure exist. So we have this 0 with multiplicity 2. So that's 2 zeros so far. And then they gave us these. But imaginary zeros always occur in conjugate pairs. So we need to take the x equals 3i that they gave us, and we need to add on x equals negative 3i, the conjugate. We need to take the x equals 4 minus I that they gave us and add on x equals 4 plus I. So really, we have 4 imaginary zeros, and then we have a real 0 with multiplicity 2. So that counts twice, so that's a total of 6. 4 imaginary, and because of the multiplicity, 2 real zeros, total of 6. So the least possible degree is degree 6. All right, looking at number 11, let's use the same thought process. All right, so we have one real 0, another one with multiplicity 3. So that's 4 so far. Multiplicity 2. So that's 6 so far. So these all added together, there's 6 of these. And then we have an imaginary term here, so we need to do the conjugate. So we need to add on x equals negative 1 minus 5i. So there's 6 of these, and then there's 2 of these, so that's going to be degree 8. Factor the following expressions if possible. If the expression cannot be factored, write not factorable. Number 12 is the difference of two squares. So we can factor this as x plus 5 times x minus 5. On number 13, I noticed that every term has at least one x in it. That means we can factor out an x to start with. So that's going to leave behind x squared plus 5x plus 6. The question is, will this factor any further? Let's try. So if this factors further, it's going to be as a binomial times a binomial. X squared can only factor as x times x. 6 can either factor as 2 times 3 or 1 times 6. Either one of these pairs could give us a middle of 5, because 2 plus 3 is 5 and 6 minus 1 is 5. So we need to be very careful as we decide which one it is. Let's try 2 times 3 first. Actually, you know what? Let me pick the one that's wrong first so I can show you why it's wrong. Let's start with 1 times 6 so I can show you why it's wrong. If I factor 6 as 1 times 6, then I go inner plus outer equals middle. Inner, I have 1x. Outer, I have 6x. In order to make a middle of positive 5, I need a negative 1 and a positive 6. So that would be like negative 1 and positive 6. However, we need to look at the third term and make sure we are getting the correct sign. Negative 1 times positive 6 would make a negative 6, not a positive 6. That's how we know this one is not the right answer. On the other hand, if we use the other option of 2 times 3, inner plus outer equals middle. So we have the 2x and we have the 3x. In order to make a middle of positive 5, we would leave both of these as positive numbers. And then if we check the third term now, positive 2 times positive 3 is positive 6. So that's how we know this is the correct factorization. Well, the first factor is the difference of two squares. So we can definitely factor x squared minus 49 as x plus 7 times x minus 7. Focus your eyes on the trinomial now. This will probably factor as a binomial times a binomial. X squared will only factor as x times x. 14 will either factor as 2 times 7 or 1 times 14. Looking at the middle term of 5, let's go with 2 times 7. Inner plus outer equals middle. Inner is 2x. Outer is 7x. To get a middle of positive 5, I need a negative 2 and a positive 7. So that's going to be a negative here and a positive here. Now I notice that we do have a repeated factor. Because of the repeated factor of x plus 7, we should group those together. So I'm going to bring down my x minus 7 and my x minus 2. But then let's write x plus 7 squared, because there's 2 of them. The following tables give values of several polynomial functions. Determine the degree of each polynomial. There is a shortcut that we can use, but only if there's a common difference between the input values. From 1 to 4, that's 3. From 4 to 7, 3. 7 to 10, 3. 10 to 13, 3. 13 to 16, 3. Therefore, we can use the following shortcut. I'm going to find the differences between the output values. The first time I do that, I'm going to call that the first difference. If the first difference is a constant, then it's degree 1. If the second difference, the difference between the differences, if the second difference is a constant, then it's degree 2. If the third difference is constant, it's degree 3, and so on. So let's find the first differences. These are the first differences, and they are not constant, so this is not degree 1. Now let's find the second differences. The second differences are still not constant, so this is not degree 2. Now let's find the third differences. The third differences are all 2. Since the third difference is a constant, this polynomial would be degree 3. For number 16, we see a common difference between the input values, so we can use the shortcut again. The first differences are not constant, so this is not degree 1. However, the second differences are all negative 1, a constant, so g of x is degree 2. For number 17, we see a common difference between the input values, so we can use the trick. The first differences are not constant, so h of x is not degree 1. The second differences are not constant either, so h of x does not have degree 2. The third differences are constant, so h of x has degree 3. The graphs of several polynomial functions are shown below. Use the graphs to find all intervals of x that satisfy the given conditions. Where is f of x less than 0? That's going to be where f of x is below the x-axis. Notice it does not say less than or equal to, so it's going to be like we have open circles wherever f of x is equal to 0. So f of x will be below the x-axis on the interval from -4 to -1. Use parentheses to not include the endpoints. And then f of x is less than 0 on this interval from 1 to infinity. And put a union sign in between. So union interval 1 to infinity. F of x equals 0 right where it touches the x-axis. So just these 3 specific points and nothing else. So we will not use interval notation. Technically, if I want to use set notation, I would use a brace like this. This is what you use when you're going to list a finite number of elements. So -4 is one value, -1, and +1. Where is the graph of g less than or equal to 0? So it's going to be equal to 0 right here. Because of the or equal to sign, think of this as a closed circle. So it equals 0 here, here, and here. Now, less than or equal to 0 will include this point and any point where g is below the x-axis. So that's going to include all of this, but then it's also going to include this. There's no need to separate this into more than one interval because all of this is below the x-axis and we are including the endpoints. So we can simply say the interval from -infinity to 0. We are going to be careful to use brackets on the end for the 0 because 0 is included. We want to know where g of x is less than or equal to 0, so we need to include 0. Union, and now we have this interval that goes from 4 to infinity. Notice that closed circle, 4 is included, so give it a bracket. When we think about where g of x is greater than 0, not equal to 0, use open circles so you don't accidentally include these endpoints. Nothing is going to happen here because no part of g is above the x-axis in this area, so you can almost forget about that. The only part that is above the x-axis, greater than 0, is on this interval right here. This is from 0 to 4. You're going to use parentheses to show that the endpoints are not included. Open circles. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.